Hello students, today we'll discuss all the examples given in notes. So our first example is a raised to n b raised to n where n is greater or equal to 1. Turing machine to design a raised to n b raised to n. We have already done this in our first video. So we'll go directly for the second example. That is 2's complement of a given number. I think you remember we have done this in Moore machine. Take a minute and recall what you have done in Moore and Millie machine to design Moore and Millie machine for 2's complement. If you remember, what we had done is we assume that the input is given in reverse order. But in Turing machine, that is not required. We can give the string or the number in the same order. Okay, so after that, read from the right, move right until blank, then move left, keep 0 as it is. If first 1 is encountered, keep it as it is and move left, and then change 0 to 1, 1 to 0. I think you remember this. Okay, if I have example as 1, 0, 1, 1, 0, 1, 1, and I think you remember this, that every string has a blank at the start and the end. So what the rule says, read from right, move right until blank, then move left, keep 0 as it is. If first 1 is encountered, keep it as it is. So for this, what we have to do, your head is here, 1, keep it as it is, 0, keep it as it is, move right, 1, keep it as it is, this one, keep it as it is. You're just moving right till you get a blank, because we are applying the rule from right to left. Now we have moved till blank, so what has to be done? Move left. Keep all ones as it is. 1, keep it as it is. This one, keep it as it is. First 0, keep it as it is. After first 0, what do you have to do? You have to complement these numbers 1 to 0 and 0 to 1. 1 to 0, 1 to 0, 0 to 1, 1 to 0. So this is your 2's complement. So how to do this now? Using Turing machine. See this. What is our first step? Go to right till you get a blank. Whatever you have, any number of zeros, keep it as it is. Any number of ones, keep it as it is, and just move right without doing anything till you get a blank. As soon as you get a blank, you have to move left. Okay, blank and move left. Okay. What is the next step? Any number of 0 from right to left, keep it as it is and move left till you get first one. The first one is kept as it is and move left. And after that, 0 is converted to 1 and 1 is converted to 0 and just move left till you get a blank. I hope this example is clear. This is your 2's complement. The same thing is given in your state table. The transition diagram has been converted to state table. Okay. The next important example is design Turing machine as generator. That is, design Turing machine to convert 110 to 101. If you remember, we have done this in Moore and Millet machine, but there only the last element can be converted. But in Turing machine, any number can be converted to any given number. The last digit only can be converted in Moore and Millet machine. But in Turing machine, any digit, any place can be converted. Okay. So, now in this example, it is convert 110 to 101. So, how to do that? We'll take an example. One, 0, 1, 1, 0, 0, 1, 1, 1, 0, blank. What is our question? Convert 110 to 101. So your Turing machine starts here. You got a 1. So maybe the next element is 1. So move right to check whether it is 1. The next element here is 0. So it is not 110. So restart the search for 110 and move right. You got 1. So the machine thinks that the next element is 1 of 110. So move right. You got next 1. So the machine thinks that the next is 0 and it will get the search and it will search for the next element and it is 0. So now we got this 110. So 110 has to be converted to 101. After getting 110, then only the machine converts it to 101. Okay. So this 0 is now converted to 1. Move left and this 1 is converted to 0. Now 110 is converted to 101. Now it has to bypass this 1 and read 0. 0 is kept as it is. Next move right. 1. It will restart its search again. Okay, again it will search for 110 if there is any occurrence of 110 in the string. So next it got 1. Move right again. It got 1. So it may be 110. No. Next is it gets 1. Next it has 0. Again if you can see it got 110. Now this 0 is converted to 1. Move left and convert this 1 to 0 and bypass this 1 and reach the next one. This is repeated till you get a blank. So if you see our output is 1, 0, 1, 0, 1, 0, 1, 1, 0, 1 and blank. The required output. So how to design this in Turing machine now? We'll see that. See this. So any number of 0 just move right because we are not getting the first one that we require in 110. So just move right. It got 1. So keep 1 as it is. Move right thinking that the next may be 110. Okay, so move right. If you get a 1, move right. Keep that 1 as it is, or if it is a 0, come back to Q0 in search of first one of your string 110. If you get a 1, move right, thinking that next is a 0. If it is not a 0, if it is a 1, it will repeat itself and move right. And if it is a 0, then what has to be done? The 0 has to be converted to 1 and move left. Why we are moving left? Because the previous one, 110, 0 has been converted to 1. The previous 1 has to be converted to 0 now. So, move left and convert that 1 to 0 and move right again in search of next string 110. Next substring 110. Search again for 110 in the string. I hope this is clear. Okay, and anywhere if you get a blank, see in Q0, Q1 and Q2, anywhere if you reach the end of the string, you can move to the final state. But one thing if you observe here, we are not reaching the final state from Q3 and Q4. Why? Because once I get 110, that has to be converted to 101. I cannot reach a blank after I reach Q3 and Q4 because I have read 110 here. I cannot reach the final of the string, the end of the string here. So if I get 110, I have to convert it and then I can reach the end of the string if there are no more substrings 110. I hope this example is clear. Okay, so in this video we have done 2 examples. One is 2's complement, Turing machine, and the second one is Turing machine to change every occurrence of 110 to 101. I hope this is clear. Thank you.